Hi. So here in this video, I'll be talking about LCD interfacing with 8051 microcontroller. So before going with the interfacing part, we should know that how LCD looks like and what are the like pin diagrams and like which pins does which thing. We should know that. So coming to our here we have this our LCD display. Here this is the physical image. So here we can see that we have a LCD display. This is especially 16 cross 2 LCD display. So here we will be having 16 columns and 2 rows, like, yeah. So like this is the first row in which we can write data, and here we have another line, another row, like here also we can write data. So to write data, we have to use these lines because these are the only communication ways using which we can write it. Yeah. So we have different these pens, and each pen have its own specific use. So coming to this, like VSS, VDD, and VEE here, so we can see that like we have this VSS to be like this is our ground. VDD is like our plus like positive power supply, and here this is you can take like zero or negative as well, like it's okay. So VEE. Okay, so like here and here comes the main parts. Like we have these control registers, and this is our data register. Data register, or you can say like the like using these pens, we will be sending our required data to our LCD display. So we have RS, RW, and E. So let us come to like what does these things do? What these things do? So here we have RS, RW, and E's. So just like whenever you need to write data into LCD, you need to use these pins. Like you specifically need to use RS, RW, E, and all these data pins D0 to D7. Okay, so coming to the RS, like RS means register select. Here register select mention tells that, okay. So before going with this, to write data in LCD, we have two types of two type like two steps, like to whenever you need to send some control instruction, like move this cursor to this, and like a clear screen, and all these are commands. So and another type of data we will send to our LCD display is our actual data, like whatever we want to display in this. So here we have two types of data we will be sending to is LCD display, and these are like they command instructions, and the data actual data we want to display. So like whenever we will be sending our data through D0 to D7 of 1 byte in 1 byte data, or like a 1 byte command. So like to differentiate between those, we have to use RS, register select. So whenever register select will be zero, we will be like considering it as our command instruction, and whenever it will be one, yeah, it will be our data, like the D0 to D7 will be containing our data. And coming to read or write, so yeah. So whenever like whenever we want to write to LCD display, we will be like making it to be zero. RW pin will be becoming zero for like whenever we will have to write. This is active high and this is active low, so that's why like whenever we have to read, we have to make it one, and whenever we have to write, we have to make it zero. So this is clear, and this is required like whenever we want to read or write, whenever we have to do some read or write operation, we have to make this an pin enable. So like so suppose I need to send data to LCD, I need to enable this pin, and then we can send data. And after sending data, we have to uh, make it zero. Like from now onwards, we will not be sending any data. And here D0 to D7 contains our data lines. These are data lines. Yeah, so like these are the main things we need to consider while writing code. So coming to our code logic. So okay, so here I'll be using here we will consider this problem. Like we need to suppose we have to display a good morning in our LCD using 8051. So here for writing code, I am using an IDE which is of Keil Microvision. And to test our circuit, we will be using Proteus for testing. Yeah, so okay, so like I have cleared. Here I have a .c file. Here you can write this logic using a assembly language as well, but that will make our logic too, like our code too long. So instead of that, here we are writing logic in C, but we can write in assembly language as well. So yeah, coming to our code, the main thing while writing the code is to include. Okay, the C is general purpose programming language, and here we have to use some use like we have to we should have access to all the pins in the microcontroller. So for that we will be including a library which contains all the registers like after including this we will be having access to all the registers of 8051. So like the library is register 51. Here this library contains all of the register informations that are needed to in microcontroller 8051. So okay, this is our main logic. This is the a simple code which yeah, this got built after compiling. Yeah, this got compiled. So this is the code, we can burn it, but this does nothing. So we have to display this. So as I said, like we have these control registers and these are data pins. So let us define like here we can easily like access those pins, but for our easy purpose uh, we will be using some different type names using which like we will not be making any mistake. So here I am making rs to be like okay. So so before doing this we should know our circuit, like which using we will what pin we will be using for like to access these pins. So before doing this we should know our circuit diagram, like which which pins will be connected to which port of microcontroller. Yeah, so here I have one diagram, I guess. I have already built a circuit. Yeah, yeah. So here we can see this is our 8051 microcontroller. Here we can see this is our port 0, port 1, port 2, and these are port 3, and these are some extra pins. So as of now we don't need these, but yeah, okay. So coming to this okay, this is not, these are not sorted, actually this is the another data line. Yeah, okay. So here we have this. So here we can see these D0 to D7 are connected to P2 to P7, and and to control these RS, RW, and E, we are using P1 port, like P1.0, P1.1, and P1.2. So yeah, okay, we have to make okay, yeah, this way. Okay, so So here we can see p1.0 points to which rs. Okay, so like we will be making uh, I am declaring a bit variable which points to p1.0. Okay, and I am using rw as well, which is pointing to p1.1, and we have this enable pin pointing to p1.2. Fine. Yeah, so we have this, and as of now we can use this to, okay, so just remove this actually we don't need anything as of now. Okay. Huh. So, and we have connected this. Okay, so we can directly send our data through our p2 pins. Okay, so and here we will be using these as our output ports. P2 will be our output port. So we will making initially to be 0 to act as output port. So no, that's it. And coming to our main logic. Okay, so as I said, like while writing our code, we have two types of commands. Command instructions and data instructions. So we will be making two functions, and we will be using them all the time to whenever we want to send any data to LCD display. So as I mentioned, we will be having two types, like the LCD command, or we can say LCD CMD. And here we will be sending one byte instruction, or we can say we will be having unsigned char, and we can name it anything. And here, okay, and here we will be having two types of instruction, or suppose LCD data and unsigned char ch. Okay, we are having two types of instructions whenever we want to communicate with our LCD. So as I said, whenever we want to send, so coming to LCD command only first. So suppose we have to send some command instruction to microcontroller. So sorry, LCD display. We will be using port 2. So here I have this command instruction. This ch here contains command for C for our LCD. So we will directly assigning to port P2. So it will go to D0 to D7, and making, here we will be making RS to be what, like here we are using command, giving command, so it should be 0. And here we are writing to our LCD display. So here we will be making 0, because this is write is for active high, sorry, active low. And here we have enable, here we are sending, and we have to wait some time, as like the LCD display internally have some time delay, it takes around 450 nanoseconds, I guess. Yeah, I remember. It takes around 450 nanoseconds, and we have to wait. After sending this, we have to wait for um, 450 nanoseconds. So here we can provide delay here for some milliseconds, I guess that would be fine. And after that we can make it to be 0. Okay, so this is our command instruction. And coming to our data, the entire logic will be same, but the difference will be only making this to be 1, and else and other instructions would be same. So okay, so these logic should work. Yeah, so can I run it? No, because like whenever we start sending data to LCD display, we need to define some things. So initially we will be sending our first instruction to be like defining our what type of display internally we will be using. We need to set that. Okay, so we have to use some commands. Here we can see, these are our commands. in a hex form. Here we can see, like, first we need to set our, like, we will be using two lines, and we have 5 cross 7 matrix inside that. So we will be sending 0 cross what it contains in hex 38. So we will be sending LCD, and we will be providing delay after that. And after that we need to, like, clear the screen. So we will be clearing the screen, or okay, so we have to make our display on and cursor on. Yeah, that thing only. Yeah, so we will be making cursor display on and cursor blinking. So 08 we will be doing this, and after that we will be providing some delay, and after that we can write a normal, we can write data as well. So suppose I need to write some character A, suppose, and after that I can provide delay, or like I can wait. Okay, so this will do something, but because I have nothing to do after that, so I'm just making an infinite loop here. So let us run it. Okay, so here there is some problem. Okay, I didn't wrote the delay command. So let us, like, we can use a normal for loop, but if we want different, we can use some timer registers as well. Internal timer of 8051. But here, as we don't need some, here we are not here we don't care about some precision, so here we can, here a normal for loop will work. Here we don't want any exact time delay. Okay, here, okay, this is our embedded system, so we have to make define as global. Okay, and this is our 1 byte, I guess. So this one work. Let us make some around 200 only. Yeah, so it worked, and like I need to uh, burn my code into this microcontroller. So here I'll be selecting my code. So this, here I have this in my Keil C51 examples. Hello, and this is my logic I build at right now. So I'll be burning it. Okay, it got burned, and here I am starting right now. So okay, I guess there was some issue. Okay, let me just figure it out. Yeah, so I got my mistake. Actually, here we can see, like, we here I am making, giving 0 cross 08 instruction, which makes display of and cursor of both. So here that's where we are not getting our data. So to display our data, we have to make cursor display on and cursor blink, cursor also blinking, like when, but if we want to see our cursor. So I need to change my instruction from 0 cross 08 to, say, A. No, E, sorry. Okay, so here now I need to again burn my code and install it in my microcontroller, and I guess this time it should work. Yeah. Okay, so here I just changed some code, like I am writing in my internal loop. So making it simple, I'll be just writing A 2 times. So that's it, and okay, that's it. Here I just changed some time delay from 200 to 50, but that does not makes any change. So after burning my code, I'll be again installing this, and I guess, yeah, yeah. See, here as we wrote A 2 times, so that's why we are getting this here 2 times. That's it. And suppose if we want to display some name, so let us make like str equals to good morning. Okay, this would be too long. I'm not sure. Okay, so let us try this. Okay, good morning YouTube. And here I do 4 4 like 4 plus 7 4 4 plus 11 11 plus 7 18 18 plus 2 spaces 20. So here we have 20 characters. So instead of, okay, we will be writing a for loop. mm, and j equals 0. We define globally, so j less than 20, j plus plus, and we have to send this data to our LCD. That's it. And we have to pass our array str of j. I guess this will work, but okay, yeah, this should work. And let us try. Okay, that is getting overflowed, but yeah, our code is working. Good morning, YouTube. That's it. Yeah, so guys, thanks for watching. Yeah, as every video says, do subscribe.